What's up, guys? I'm making a GUI in Rust, and I wanted to share the things I came across. SDL is an abstraction layer, so instead of calling these platform-specific APIs for creating a window or whatever, you can just use SDL, and then it will handle all of that for you. I also really like SDL because it's a simple interface, and it makes it easier to understand. But the problem with SDL is it's a C library, and C is a really old language. At the end of the project, I don't want to have to worry that I forgot to free something somewhere. And a lot of these more modern languages give a better sense of completion at the end. Plus, C's build system is really bad. I don't want to have to use make or CMake to work with this project. And something like Go's packaging system or Cargo from Rust would remove a lot of headache. Also, if I'm using C, I'm missing out on some language features which I would end up just re-implementing anyways. So might as well just work with a good base. So I chose Rust because it's good, and fortunately there's already a wrapper for SDL that was built in Rust, so that removes a lot of work. But the issue is there were some problems with this wrapping. I saw missing features, unsafe stuff, and incorrect API, so hopefully my merge requests are reviewed at some point. For now, I'm just using my own development branch. User interface is composed of widgets, and these widgets form this tree hierarchy. So something like a layout can contain other things like buttons and text inputs. The way I've set up this library is the child's widgets will have sizing information, and then the parents will then respond back with where it should be drawn. I've used other GUI libraries in the past, and they've always had some sort of minimum, maximum, and preferred size. So Java Swing does that, and Qt does that. With this library, it instead has a preferred portion. So in this example, it would prefer to be 50% of the parents. And in cases where there are multiple competing components, then this is treated like a weighted average. So you can say that a component is one-third the length of the parents. This allows things to scale pretty nicely. The widget also provides length failure policies. So this says what happens when the parent is too big or too small. For example, if you have some text that's in a very large area, then would it be left aligned or right aligned? And with this preferred portion and lengths and whatever, it's best to represent things as floats. And then right before it's drawn in the user interface, then it snaps to an integer position. I thought that would be easy, but there are a lot of things to look out for. For example, the default rounding behavior for floating point numbers is if you're halfway between two numbers exactly, then it will round away from zero. I think this is enforced in hardware. But the issue is that would be inconsistent because then some things might round positive and then other things might round negative. Just weird things where I'd be staring at a screen going, why is the widget 1 pixel off? Anyways, a widget also provides an aspect ratio. So in this example, the left three are just accepting whatever ratio is given to it, and then it will stretch or zoom out or zoom in respectively. But the one on the right is telling the parent that it wants a 1-to-1 aspect ratio, and then the parent will then give it an appropriate position. This is something that's calculated dynamically. So for labels, the aspect ratio is dependent on the rendered text. And something like a vertical layout will calculate the heights first, and then given a height, what should the width be for that widget? After the position for a widget is known, all of the widgets will then be updated, and then they'll all be drawn. And these are two distinct steps. And to explain that, I want to talk about physics simulations. So in a simulation, you have a state, you have a rate which can be applied to the state, and once it's applied, you get the next state. So position would be a state, and a velocity would be a rate. But states and rates could be more abstract things. So, for example, in Conway's Game of Life, the states are each of the 2D cells being dead or alive, and the rate would be the rules that cause the cells in the next frame to be dead or alive. If you were to naively apply the rules for Game of Life, then it would look something like this. You'd have the top left cell, it's got 3 alive neighbors, so in the next frame it will be alive. Following that, there are 5 neighbors, so then it will be dead. And if you continue this pattern through all of the cells, you get this really weird looking asymmetric pattern, and it's not right. The issue is that we're mixing the old state and the new state when we're calculating the next state. So the cells that are above or to the left of the current cell are looking at the new states instead of the old states. If you were to instead do this correctly, then you would create a brand new state and you would populate the cells in the new state by only looking at the cells in the old state. The same thing happens in the user interface. So in this example, we have a focus manager, and this is something which points to a specific widget in the interface. So if you're hovering over something or you clicked on it, then that widget will be focused, and then when you type, then the text inputs will go to the focused widget. So in this example, let's say we have the 2 widgets. The one on the left will be updated first, and then the second one will be on the right. And the focus manager is currently pointing at the second one. So what will happen is the first one will get drawn. It'll be drawn as it's in an unfocused way because the focus is not on it. Afterwards, we'll move on to the next widget. That second widget, let's say you type Shift Tab, it will then adjust the focus manager so that it's pointing to the previous widget, and then it will draw itself appropriately. It does not have focus right now, so it will also be drawn unfocused. This is an issue because now you have a frame where nothing is focused, but at all times, at least one widget should have been focused. And the issue is that the first widget drew itself using the previous state of the focus manager. So this is another case where we're mixing states. And if you instead updated everything and then drew everything afterwards, then it would avoid this problem. That fixes issues between updating and drawing, but there still could be dependent elements within the same update frame. For example, if you have a text input and when you enter text, then it'll change the state of some display. And this is fixed by giving some flexibility over what elements are updated in which order. So you can have the dependents updated before the dependees. The default widgets that are part of this library have an interface so you can specify the style. So the style will allow you to render the texture that will be displayed under certain circumstances. And the textures will be reused appropriately. So for a border style, it will only be re-rendered if the size of the border changes. This is an immediate mode GUI, one of the implications being that it will redo the sizing and positioning of everything each frame. So the widgets can be connected together each frame, but for widgets that cache textures, they shouldn't be dropped each frame. For example, a software rendered background, it might take 1 millisecond to render, but considering that a frame lasts 16 milliseconds, that's still a sizable chunk, and it shouldn't redo that every frame. You should reuse the same background, and then it will use the same cached texture, or it will make it bigger if it needs to. And to do, number one, there's no audio. SDL has a whole audio subsystem. I just haven't gotten to it yet. And also the default styles are kind of scuffed. So what I might do is try to improve those with some better rendering.